Uh, oh, there we are. It's recording now. Hello, Aslam class. Welcome to your maths lesson today on the 28th of January 2021. Um, so in today's lesson, this week, we have been looking at, we finished off with area at the beginning of the week, but now we've been focusing on fractions. And what we've been doing, we've been recapping work that you would have probably done last year. So don't worry if you find the work on fractions a little bit too difficult or you're a little bit concerned and worried about it. This is stuff that you should have done last year. You didn't do it last year because of the pandemic. So we're recapping it and going over it now. Okay. Fractions can be quite difficult. They can be hard to understand, but we're going to take it as slowly as we can, so you can sort of catch up the best you can. This week we looked at non-unit fractions and unit fractions, and we're just reminding ourselves that a unit fraction is a fraction where our numerator is 1 and our denominator is a whole number, and that can be any whole number. And a non-unit fraction is when our numerator is greater than 1. Our denominators describe the whole part of a fraction. That's how many parts we have. And the numerator is how many parts are we looking at of that fraction. I hope that makes sense, because we're going to move on today looking at fractions of amounts or fractions of whole numbers that we have split into tenths. Okay. But as always, with our maths, as with maths, we always start with our arithmetic. And here are arithmetic questions for today. So what you can do, if you pause the video, we can then go through the answers. Again, it shouldn't take you too long to do, but pause the video now and good luck. Okay, welcome back. Hopefully you've had enough time to get that work done. I'm going to switch over to my camera here. Excellent. Okay, I've written down all my questions here, so I'm going to make this bigger so you can just see how we do this. So for question 1, I already started. 5 times 7 gives us 35. 18 divided by 3. Now the wording here says, what is 18 shared into 3? Okay, so we've taken 18 and we've shared it into 3 groups, and in each group we get 6. The next one is, what is 823 as a Roman numeral? So remember, Romans they didn't count like us, they were very different. So 800 would be, we first used 500 because they had a value for 500, and that was D. We then need to, so that's 500 at the moment. We then need to add on 3 more hundreds to give us 800. So 1, 2, 3. So that represents 800. We then go on to our tens. There are 2 tens, and in Roman numbers, tens were x's. So we've got 2x. Okay, and then for 3, we just have 3 ones or i's. They look like that. So you should have 823. DCCCXXIII. Question 4. When you have a look at this number sequence, you should find out that unfortunately it doesn't follow any sort of pattern in adding numbers. 1 plus 2, 1 plus 1 is 2. And then 2 plus 1 is 3. And then 3 plus 2 is 5. 5 plus 2 is 7. And then 7 plus 4 is 11. So there's no real pattern going on there, but what you hopefully have recognized that these numbers are actually what we call prime numbers. Now there's always a debate whether 1 is a prime number or not. However, these are all prime numbers. So the next prime number after 11 is 13. So that's your answer. 9 times 9, you should know your times tables, is 81. 32 divided by 8 is equal to 4. Now, 3 kilometers into meters. If we are converting kilometers into meters, we need to multiply by 1,000 because there are 1,000 meters to every 1 kilometer. So 3 multiplied by 1,000 gives us 3,000 meters. This question here, let's have a look. We've got 6,000 plus 2,000, which is 8,000. 700 plus 200, which is 900. 800, ooh, this way won't work. So let's think about this one. I've now noticed that I'm going to have to exchange. So I may want to quickly write this down like this. 8 plus 1 is 9. 8 plus 3 is 11. Then I have to exchange 10 tens for 100. 7 plus 2 is 9. I then have to exchange, add that on, so that becomes a 10. And then 6 plus 2 is 8, add that 1 is 9. So we should have 9,019. For this question here, I'm then going to do 9,000 take away 2,000, which is 7,000. 800 take away 400, which is 400. 70 take away 60 is equal to 10, and 5 take away 2 is equal to 3. So our answer is 413. And then our last question, 42 divided by 7 is 6. So these are all your answers. I hope you did a good job. You can pause the video here to check that you've got your answers correct. Okay, let's go back so you can see my face again. There we are. So today we're going to be talking about a tenth. Do not pay attention to this. I forgot to edit that. To understand what a tenth is. And today you're going to be doing work, understanding what a tenth is, and hopefully counting up in tens. So here is a quick challenge for you. What I would like you to do is have a look at these numbers and write down what each digit represents. So what does the 4 represent? What does the 3 represent? What does the 6? What does the 9 represent? Then I want you to try and rearrange the digits to make the smallest and largest number. And then can you make it an even number? Okay, so can you use all these digits and make an even number? Off you go, a couple of minutes, pause the video. Good luck. Okay, welcome back. What you should have been able to do here is recognize that all of these values are the following. Our 4 here is representing 1,000. Our 3 is representing 100. Our 6 is representing tens. And our 9 is representing 1. So well done for getting that correct. Now, can you rearrange the digits to make the smallest and largest numbers? So in this case, look at we want to make the largest number. So our largest number is going to obviously be in the thousands column, isn't it? And which digit is the largest digit here? It's the 9. So we would move our 9 to the 4, okay, to the thousands. So if we wanted to make our largest number, we put our 9 in the thousands column. Then we have a look at the hundreds column. What's the next largest digit that we can use? It's the 6. So that goes in there. And then we've got a 4 and a 3 left over. We don't want to put the 3 in the tens because 30 is less than 40. So let's put 40 there and then 3. So that is the largest number that we can make. Now the smallest number, we just have to do it in reverse. We want to use the lowest value for the thousands, which is the 3, okay, followed by the next lowest value for the 100, which is the 4, and then the next lowest for the tens, and then the last digit, obviously the highest digit being in the ones column. Can we make this an even number? Yes, we can. It doesn't matter what digits we have to rearrange to begin with, as long as our last digit in the ones column ends in either a 4 or a 6, then you've made it into an even number. And that's just one example for you there. Okay, good, let's move on. So all numbers, this is just to to give you an idea of where a tenth is in a number. We're not really going to be looking at decimal points at the moment, but I thought it would be good for you guys to understand that every single number that we use has a decimal point. However, we only show numbers after a decimal point, and we only show the decimal point if our number is not whole. Okay, so for example, the number 7 is a whole number. We don't write 7.000. There's no point. It's a whole number. We just put 7. However, if we were to divide 7 by 2, we would have 3 wholes, and then we would have a half in each group. And that is when we would use a decimal point, and a half is represented as 5, because when we look at values in all place value holders, once we get to 10, we start again. Yeah. So 5 is the halfway point between 0 and 10, and that's why 0.5, or here in this number we call it 123 and a half, because 5 is halfway between 10. And that's what we're looking at today. We are looking at the number that we would put in this place in our, if we were writing a number, we are looking at tenths today. I thought it would just be interesting for you to know where a tenth is, but don't get too hung up on this. It's just very quick. This is where it is in a number. So tenths are fractions that always have 10 parts, okay? And I'm going to quickly show you on my lovely new tool that I've got. Now, where is it? There we are. With my new camera to help me out here. Okay, here we've got a one hole. Okay, I've got one hole. Okay, and I've split it up now into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have my one hole that I had here. I've now cut up into 10 equal parts. Each one of these is known as a tenth. Okay, and a tenth is what we're looking at today. So each one of these represents a tenth. So if we were to write a tenth as a fraction, I'll write it down here, it would be 1 over 10. Our whole has been split into 10 equal parts. One of these is a tenth. Okay, it's one part, okay, out of 10 to make us a whole. Can you see that? So here's our whole. We've split it into tenths. This is 1/10 of a whole. Okay. Well, that'd be interesting for you to see that. So when we have a look at the board now, okay, the question, it asks us, have a look at the counters. How many of these counters are yellow? Okay, so 3 of the counters are yellow. We go 1, 2, 3, and we've got 3 yellow counters. How many are red? 1, 2, 3, 4, 5, 6. So 6 are red. And then how many are green? 1. When you add all these values up together, we get the magic number of 10, and that shows us that that is made a whole. And you can see here, if we did it here, 3/10 are yellow, 6/10 would be green, red, sorry, and 1/10 would be green. So if you were to write that as fractions, it's 3 out of 10 were yellow. We would then have 6 out of 10 that are red, and then we have our 1 out of 10 that is green. Okay, let's make myself just a tad bit smaller there. Okay, so we can actually use part whole models to help with fractions, and I'm going to keep this screen up here so that we because we may always come back to it. So it's better than looking at my face all the time, I suppose. Right, so we can use part whole models to help with fractions, so that we can see how we do things. Bring my book in here. So, move the camera. Let's bring my book in here to help out as well. So here we've got one whole. Okay, we have 3/10 is one part. How many more are going to make up our whole? So let's use these to help us. If you've got blocks and things like that at home, you can please use them, it will help. So here's our 3/10, okay, that we've got, and I put them over there. And then how many more tenths do I need to make up my whole? So let's get my whole. Let's get the whole up so we can see it. Hopefully it'll fit in the whole screen. There we are. So we've got our 3. How many do we need to add on to get to one whole? We go 1, 2, 3, 4, 5, 6, 7. We've had to add 7 more tenths to our model to make up one whole. So 3/10 and 7/10 makes one whole. So I'll put it here, 7/10. Excellent. Now I want you to have a go answering these questions. So what you need to do is the following. You need to tick the pictures that show tenths, and remember, as tenths is when a whole has been taken and split into 10 equal parts. And then I want you to finish this part whole model on the side here. You can pause the video and and answer them questions. Okay, guys, let's see how you've done in answering these questions then. So, tick the pictures to show to show tenths. So remember, a tenth is when we divide a whole number or a whole bar, rectangle, whatever, into 10 equal parts. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, we can tick that one off. Okay, the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, they show tenths as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is not showing a tenth because it's split into 12 parts. 1, 2, 3, 4, 5, 6, 7, 8. That is only showing us 8 parts. They're called eighths, and we're looking for tenths. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should be ticking this one. And here we've got also tenths. Okay. We have 10 beads there. Over here, we use the part whole model. We have one whole and we've got 7/10. So I'm going to show you this very quickly. So here we've got our one whole, which is brown. We've got 7/10 on top at the moment. Okay, you can see they're all split up. We then have to add 1, 2, 3/10 to make our one whole. So it's 3/10 that go over here. Okay, so we need to make up 3/10 to get to 10. Basically, we've got 7. How many more do we need to add on to get to 10? The answer is 3. Okay, so for your independent tasks for today. Now, if you've got access to cubes, if you're in school, use them. If you don't have access to cubes, maybe use some Lego bricks or objects that you can see around the house, preferably of the same size, to get you to understand tenths. And try to make them different colors if you can. If not, it's not to worry. You can use this picture to help you. Task number 1. Amir has blue and yellow cubes. He makes a tower using 10 cubes. Investigate how many towers Amir can make with 10 cubes if every tower has a different number or fraction of blue and yellow cubes. Okay, so that's your first task, and everyone should be able to do that. If you want to push yourselves though, and you want to do another task and you want to challenge yourself, you can go on to challenge number 2. Danny has a bag of sweets. Half of the sweets are red, 3/10 of the sweets are yellow. The rest are green. What fraction of the sweets are green? And if you really want to push yourself, try this one out for size. Mo also has a bag of sweets. 4/10 of his sweets are red. The rest are green or yellow. What fraction of Mo's sweets could be green and what fraction could be yellow? And how many possible answers have you found? So they're your 3 challenges. Please give number 1 a go. And then, but you're not under any expectation to do all 3. But for those of you who want to push yourselves and to strengthen your knowledge in fractions, then you go on to the next challenge. And if you want to do more, there's just 1 challenge left for you to do. So there we are. You can pause the video and then I'm going to go through the answers. Okay, the answers for you. Okay, so here we've got an example. Okay, and he's making 10 cubes, and if every tower has different fraction of blue and yellow cubes, so how many different towers can he make? Let's just concentrate on blues for the minute. So for if he was using yellow and cubes and he had 10, he could make 9 with yellow, which would mean the blue would be 1 out of 10. That's 1 tower. Okay, 9 yellow, 1 blue. And then 9 blue, 1 yellow. And then we look at our example here. We've got 8 that are blue, and then we got 2 that are yellow. Okay, and then we keep on working along until we've done all possible combinations. And when you go through all of the combinations, you should find out that there are 9 different towers that he could make using different amounts of yellow and blue bricks. Now, if you went on to this one, Danny has a bag of sweets. Half of the sweets are red, 3/10 of the sweets are yellow. The rest are green. What fraction of the sweets are green? So let's have a look, and we can use our bar model here to help us. Okay, let's say our bag of sweets are the brown. The 1 whole is our bag of sweets. Half of them are red. Okay, so half of them are red. Now, how do I know how many to take off to get a half? Well, we know that 3/10 of the sweets are yellow. So if we were to convert our half into tenths, what is half of 10? And the answer is 5. So I know that 5/10 are representing my half. Okay. I've then got 3/10 that are yellow. The rest are green. How many tenths do I have left? I have 1, 2. So what fraction of the sweets are green? They are 2 out of 10. Because if we're using tenths here, we know 3/10 are 3/10, but half of 10 is 5. And then for the last challenge, Mo has a bag of sweets. 4/10 of his sweets are red. The rest are green or yellow. What fraction could be green? And what fraction could be yellow? Now, I may have loads of different answers for this, so I'm only going to give you a few. So we've got 4/10, 1, 2, 3, 4. Okay, these 4/10 represent red sweets, and I'm going to move them out of the way so we can see what we've got left. We now have 1, 2, 3, 4, 5, 6/10 left. 6/10 of them could be green. 6/10 of them could be yellow. We could have 1/6 be green and 5/6 be yellow. We could have 2/6 being, or 2/10, sorry, being green, and 4/10 being yellow. Okay, so we've got 6/10 to play with. You then need to organize which ones could be yellow, which ones could be green. Okay, so for example, we could have all of them could be green. So that would be 6 out of 10 would be green, or we could have 1/10 being green and 5/10 being yellow. So think about all the different combinations that you could have there. Okay, and put your answers up on the tapestry, and I will mark your work and see how you've got on. Like always, if you've got any questions, please don't hesitate to ask. See you in the next video, guys. Bye-bye.